So today we're going to talk about the exact value ratios for the special angles for sine, cosine, and tangent. I'm going to show you where they come from. Our special angles are 30 degrees, 45 degrees, and 60 degrees. And back in geometry, hopefully your teacher talked to you about the special right triangles, the 30, 60, 90 triangle, as well as the 45, 45, 90 triangle. We're going to take a look first at the 30, 60, 90 triangle. And when I look at this right triangle here, that has a 30-degree angle and a 60-degree angle as my two acute angles. Okay, so this is the 30, 60, 90 right triangle. That we learned back in geometry, again, hopefully you learned these ratios, that the relationship between the shortest side of the triangle, here, the side opposite the 30-degree angle, compared to the longest side of the triangle, here, which is the hypotenuse, is actually in a 1:2 ratio. So what I can tell you is that no matter what this length is, this is always twice as big. And so, again, if the short side is 4, then the hypotenuse would be 8, etc., etc. So this is in a 1:2 ratio. And because these two sides represent the sine ratio, what I can tell you is that the sine of 30 degrees is equal to 1/2. Okay, and that's a well-known ratio. That's something that you're going to have memorized. You're going to know it as well as you know, hopefully, your middle name. Okay. Pythagoras will tell us that a squared plus b squared equals c squared. And so if I use the Pythagorean theorem here to find the missing piece here, I will tell you that, of course, the 2 represents the hypotenuse, and so 2 squared is 4. And if I let 1 be my a, 1 squared is 1. And I can then solve for b. And I can figure out that if b squared is equal to 3, that b will be equal to the square root of 3. And so this leg here, this black leg, that is opposite the 60-degree side, which is the longer leg of the triangle, will actually be equal to the square root of 3. Okay? And so these sides are in a 1:2 to radical 3 ratio. Not in that order, obviously, because the hypotenuse is the longest. But I think that that makes it a little bit easier to remember, 1:2 to radical 3. So from here then, I can actually continue with my trig ratios and tell you that the cosine of 30, which compares the adjacent here to the hypotenuse, will be equal to the square root of 3 divided by 2. And so I will put that down as a special angle ratio. And then, of course, the tangent of 30 will be equal to the opposite over the adjacent. Now, the issue here is that I have a radical in the denominator, and so what I'm going to do is rationalize that denominator by using my skills that I learned back in the radical unit. Multiply by radical 3 over itself, and that will actually simplify then to the square root of 3 over 3. Okay, now I'm going to do the same thing for the 60-degree angle because I'm going to use the same triangle. That's kind of one of the nice things about this. So if I go to my 60-degree angle then, I will tell you that the sine of 60, which would be the opposite over the hypotenuse, is going to be equal to the square root of 3 divided by 2. I can tell you that the cosine of 60, which in this case will be the adjacent over hypotenuse, compared to the 60, this is adjacent to hypotenuse, and so that would be equal to 1 over 2. And then, of course, the tangent of 60, which would be the opposite here, divided by the adjacent, would be the square root of 3 over 1, but we're not going to put over 1. So those are the special angle ratios for the sine of 30, cos of 30, and tan of 30. as well as the sine of 60, cos of 60, and tangent of 60. Okay, now it is not coincidence that the cosine of 30 is the same as the sine of 60, and the sine of 30 is the same as the cosine of 60. If you think about the fact that these are complementary angles, because from a right triangle, as soon as if these are going to add up to 90, then the side opposite the 30 is going to be the side adjacent to the 60. And since both sine and cosine use the hypotenuse, the opposite of 30 and the adjacent of 30 will use the same ratio of 1 over 2. And it goes the same for the 60. The opposite of 60 is radical 3, whereas the adjacent to 30 is radical 3. And those will be over 2. So these actually kind of swap values. That is because sine and cosine are actually called co-functions. That's a whole nother day. We're going to get into that a little bit later, but just to kind of, brief you on that now. So let's take a look at the 45, 45, 90, which is our other special right triangle. Okay, so here I have my 45, 45, 90 triangle, and by nature of isosceles, because if one acute angle is 45, the other one is also, these legs are also going to be congruent, because in an isosceles triangle, you have two congruent legs as well as the base angles congruent. And so what I can tell you is that these sides are in a 1-to-1 ratio. No matter what the length of this leg is always going to be exactly the same. And then again, Pythagoras says if a squared plus b squared equals the hypotenuse squared, 1 plus 1 is 2. And so therefore I can tell you that the hypotenuse is going to be equal to the square root of 2. And so that's the ratio of the three sides of this special triangle, 1-to-1 to radical 2. So again, if I go in and find my sine of 45, sine is going to be opposite over hypotenuse, which is 1 over radical 2. I run into the same problem I had before, so I'm going to rationalize this by multiplying by radical 2 over itself, and that will end up simplifying, or cleaning up, I should say, to radical 2 over 2. Now the cosine of 45 is exactly the same as the sine of 45, because it's still going to be 1 over radical 2. And so after it's rationalized, I will end up with radical 2 over 2. Tangent of 45, because the tangent compares the two legs. No matter what those legs are, they're always in a 1-to-1 ratio, so it will always create a fraction of 1. Okay, so there you have the special angle ratios for the three angles 30, 45, and 60. What we're going to do next is put it into a chart form so that you have something to use for reference and to make it easier to memorize. So what you want to do is get a chart similar to this in your notebooks so that we can fill it in, and then you will have an easy to read and an easy to memorize chart for getting these special angle ratios. When you are asked to find the exact value of these special angles, you do need to know the radical version, the fractional version. The decimal version is not going to cut it here. And there's only 9 of them, and you'll see as we fill in this chart, there's really, it's pretty simple. There's a lot of patterns that happen, so it's a pretty easy thing to memorize. Okay, so if you haven't already gotten this copied down, pause it for a second so that you have a chance to get it copied, and then when you start it back up, I'll continue with the notes. Okay, so what we want to do is fill in these ratios, and what I can tell you is that the sine ratio of 30, remember, was 1 over 2, 1/2, 1 over 2. The cosine ratio for 40, or let's go across the sine just so that you can see the pattern. So the sine of 30 is 1 over 2. The sine of 45 was radical 2 over 2. And the sine of 60 was radical 3 over 2. Now I want you to notice some similarities here. Each of them is over 2, because they're compared to the hypotenuse on that triangle. And then this was rationalized. And the numerators just basically go 1, 2, 3. Of course, these have radicals, but if you think about the square root of 1, the square root of 1 is 1. So it's 1 over 2, radical 2 over 2, radical 3 over 2. And if you can remember that one line, then it makes this whole thing a lot easier to fill in. 1 over 2, radical 2 over 2, radical 3 over 2. And it goes in order, smallest to biggest, 30 to 45 to 60. 1 over 2, radical 2 over 2, radical 3 over 2. That's really the only thing you have to memorize, because then the cosine ratio backs this pattern up the opposite direction. So the cosine is going to start for the cosine of 30 with radical 3 over 2, because this here is going to be equivalent to this. Okay, these switch. The cosine of 45 is the same as the sine of 45, so that's radical 2 over 2. And the cosine of 60 is the same as the sine of 30, so that's 1/2. So again, it goes in order. It goes 1 over 2, radical 2 over 2, radical 3 over 2. And then it backs it up. Radical 3 over 2, radical 2 over 2, 1 over 2. So it's in the same order, but backwards direction. Okay, so for the tangent, for now we're just going to fill this in, and then later we're going to talk about the tangent ratio itself. But the tangent is the square root of 3 over 3 for the tangent of 30. Tangent of 45 is 1, and the tangent of 60 is just radical 3. Okay. So again, these 9 values need to be committed to memory, or you need to have the chart memorized or a way of getting the chart so that you can put it as a reference in the corner of your paper, whatever. But nobody's going to give you these reference angles. You have to know them. Okay. And so what will happen is they'll ask you to find, say for instance, the sine of 45 degrees in its exact value form. Now if you punch that into your calculator, the calculator is going to give you a decimal version of that. But we're going to want you to report it as radical 2 over 2. Okay? If they ask you for, say, the cosine of 30 degrees, and you punch that into your calculator, the calculator is going to tell you approximately 0.8660, blah, blah, blah. But we're going to want you to report radical 3 over 2. Okay? So just keep that in mind, that these are always exact value, and whenever you see those words exact value, that means from your chart. Okay, we're going to be using this with our reference angles then that you're going to be talking about.